Alright, so this video goes along with the third section of the review chapter, or R3, and we're dealing with polynomials. The first thing we're going to do is review some of our exponent rules. So remember that when I multiply two bases that are the same, we add their exponents. So we multiplying bases means we're adding exponents. So you can look at these examples here. When we have raising a base raised to a power, and we take that a to the m and we raise it to a power, we're multiplying the exponents. So again, up here we add the exponents, here we multiply the exponents. When we raise a power to a power, we multiply. When we're adding two like bases, multiplying two like bases, we add. If I have a product that I'm being raised to the power, that means each of the individual factors in that product each get raised. So a times b, I could multiply them together and then raise that product to the power, or I could raise each thing to that power and then multiply them. And then the third rule here, similar to the rule number 2, is that if it's a quotient or a fraction being raised to a power, then it's the numerator being raised to the power divided by the denominator raised to the power. So I would recommend that you go through and look at some of these examples. Again, this is not new stuff. This is things that you did in Algebra 2. If any of them are sort of confusing, make sure that you go back and review some of those. And some of the homework will have you do that as well. A common mistake. Let me rewrite this kind of bigger. So I have 4 squared times 4 cubed. Now we know the product rule up here says the bases are the same. I'm multiplying those bases, so I would add the exponent. So this is going to be 4 to the 2 plus 3, or 4 to the 5. Often what I see, if I had, previously, like, I don't know, 3rd grade, 4 times 4 is equal to 16. So often we see that people combine these two things and they say, oh, okay, I'm going to multiply the bases and add the exponents, and they write that this is 16 to the 5th power. Way too big. If you took 16 and raised it to the 5th power, that's a huge number. If you think here, 4 to the 2nd, that's 16. 4 to the 3rd, that's 64. Multiplying these two things together is not nearly as large as 16 raised to the 5th, right? So what's happening here is, sometimes we have, let's say I have 2 to the 2nd times 2 to the 3rd, okay? So ultimately with these kinds of things, I can either multiply the multiply the bases together. Sometimes I can. Like let's do a simpler example. So if I have 2 to the 1 times 2 to the 1, okay, so I can either, like we did in 3rd grade, 2 times 2 is 4, or I can do 2 and then 1 plus 1. But I don't get to do both. Sometimes you don't get your choice of which one to do, but you never do both those things. You never multiply these numbers together and get 4 and then also add, right? This is not equal to 4 to the 2nd power, all right? Because that's 2 times 2 is 4. Obviously, it's not equal to 16. So sometimes you can have a choice of which approach you want, but you never get to do both approaches. You never get to multiply the bases and also add the exponents. And that's kind of what this is, going through is here as well. And then one more thing, a reminder that anything raised to the 0 power is just 1. Okay. Polynomials, some common terms, which you should be familiar with. See page 26 for some common terms. Terms like coefficient, like terms, monomials, polynomials, trinomials, polynomials, degree of the term, degree of the polynomial, descending order, foiling, difference of squares, perfect square trinomials. Now some of these terms we're going to review and discuss. as we go through this and the rest of the chapter. But those are, look through those and make sure you're comfortable with all of those terms. Those are terms we expect that you learned in Algebra 1 and that you kind of remember those. And we'll talk about some of those as we proceed through the chapter as well. Let's look at some examples here then. Simplify each expression. And so simplify, in part, simplify, when we say simplify an expression, doesn't mean like find a solution, right? It just means in this case, get rid of all your parentheses, right? So add or subtract or multiply, do whatever you need to do. Write your answer, complete it without any parentheses. So here we have like terms, right? So 2x to the fourth, 3x to the fourth, those are like terms. So I'm going to combine like terms. I'm adding them here. So all the terms just get added. 2x to the fourth plus 3x to the fourth, that's 5x to the fourth. Sorry, there's not a whole lot of room there. A little tight there. We have negative 5x cubed. I don't have any x cubes over here, so I don't have any like terms. That's by itself, 5x cubed. And the same thing with the 4x squared. There's no like term over there, so that doesn't get added to anything. So 4x squared, and then finally we do have these two terms are like terms. So that ends up being plus 8x. So I've simplified this. I combined all the like terms that I could. Notice there's no parentheses in my final answer. Okay, B. In this case, we're subtracting. Really, probably the best thing to do is think about turning that into addition and changing the signs of all the things in the second. You're subtracting this whole polynomial, so those signs all change. So now we have 4x to the fifth. These are like terms. It was negative, but now it's positive, so plus 2x cubed. And then these are also like terms. Careful, that one's negative, so it's negative 2x. All right, so you distribute this negative to each of those terms, so I change the signs of those terms. That's kind of the safest thing to do. We don't like subtracting positive and negative numbers. We often make mistakes, so we'll change it to addition and change the signs of the second polynomial that we're subtracting. All right, this one, we are distributing this monomial to each of those three terms in the trinomial in the parentheses. So we're simply going to multiply these two together, then these two, then these two. So that gives us, and you should feel free to stop this video and try these on your own and then play the video, make sure you're doing it correctly. Instead of just copying down what I'm writing, it'd probably be good to try it on your own first. So this is negative 3y. Now we're multiplying the bases, so we add the exponents, so that's 6. And then we multiply these two together, that's negative 6y to the fifth. And then multiply those, that's going to be positive 3y to the fourth. And this one here, we're multiplying this times this. So we're really foiling. However, these are special binomials. Notice that they're the same, except that the sign between them is different. And so we will refer to these as conjugates. And so what that means is if I multiply these two together, well, let's first just foil that. So first, that's 4x squared. The outer is plus 10x. The inner is negative 10x. And then the last is negative 25. But notice these middle terms are going to cancel each other out. So when we have conjugates, what's nice about multiplying two conjugates together is that the center terms always go away. So it's the first two terms multiplied together and the second two terms multiplied together. So it's the product of the first plus the product of the second. So that's just going to be 4x squared minus 25. So if you know and you notice that those are conjugates, you don't have to do this center term. You can sort of jump and skip a step. Don't have to do everything quickly, but quicker is better than slower. generally. Okay, so if we look at these are not conjugates, right? So we're simplifying these again. These are not conjugates, so we really just want to FOIL these. So the first two terms, that's 15. The bases are not the same here, so m squared n cubed. And then the first, and then the outer, so we multiply these two together, so that's negative 6m cubed. And then the inners, that's going to be plus 25n to the fourth. Then finally the last, that's negative 10mn. Now there's no real reason for which of these should go first. Sometimes we put them in alphabetical. In one particular term, we will sometimes put in alphabetical order, or the order in which they are here. There's no real rhyme for which one should be first. We should have them in descending order. You know, like this one, this term has degree 4, this term has degree 3, this term has degree 5, this term has degree 2. So sometimes we might put them in descending order of the terms, but really we do that mostly when there's just one variable. Here we have two different variables, so there's no real rhyme or reason like where, you know, what's the best way to put your final answer. Okay, notice none of these are like terms, so we cannot combine any more there. And so we're pretty much done, except maybe how you might order those slightly different way. You know, this is degree 4. Maybe you'd put that one first, but you know, we really only care about descending order when it's just one variable. Like this one here has all one variable, right? Just x. So this one we will want in descending order. This one's a little bit ambiguous as to which way we should leave it. All right, so this one, it's sort of like a foiling, but it's a binomial times a trinomial. So each term here gets multiplied by each term here. So 2 terms times 3 terms. I'm going to have 6 terms when I'm finished. All right, so the first two together, that's 2x cubed. All right, so there's no one way to do this, but generally I start with, you know, just started with my x, I'm going to use it 3 times. So now it's these two. That's going to be minus 4x squared, and then these two, which will be plus 3x. And now I go to the 4, so 4 times the 2, x squared, that's going to be plus 8x squared, minus 16x, and then finally plus 12. And now here we want to definitely combine like terms and also make sure that they're in descending order. So this first term is a degree 3. We'll put it first. These two get put together, and they have a degree 2, so they come second. So plus 4x squared. The x term comes next, was at negative 13x. And then finally the plus 12. So that is your best and final answer there. Let's go on to G. So G is another, you got to be careful, the common mistake here, this is not equal to just the squaring, right? We don't get to use our rule up here. It's not this, right? That's a monomial product, a times b raised to the m. That's not what's happening here. This is a binomial being raised. So this is not somehow like 4x squared plus 16. We see that all the time, right? You have to FOIL this with itself. So think of it as, we don't generally write it out like this. I'm going to do it this one time. 2x squared times 2x minus 4 times 2x minus 4. And so it's first, outer, inner, last. So that's 4x squared. We have the outer and the inner, they're the same, so it gets doubled. So this is going to be minus 16x and then plus 16. All right, we generally don't, the idea is don't write out like this. You should be able to kind of do that in your head. If you have to, that's fine. So let's try doing it here. So this one, it's going to be the first term squared, that's 9y to the 6th. And then let's think about the last term. The last term is going to be this one squared, so plus 4x squared. And then the center term. When we FOIL this out, we'll get 2, but they're going to be like terms, just like we saw, for this one. We're going to have 2 like terms. So it's this times this, but doubled, because there's going to be 2 of them. So 6xy cubed, but double that. So plus 12xy cubed. And if you have to, write that out twice and actually go through the FOILing process, that's fine. Do that. But we kind of hope that you should be able to kind of do something like this. This is a perfect square trinomial because we could write this. This is the unfactored simplified form. But if we factor it, and we'll practice this, we'll practice in the next couple of sections going backwards and doing this. So that's helpful to be able to go back and forth through that without having to go through all of those steps. We want you to be able to save some time with some of those. All right, let's go on to I. Again, this is a binomial times a binomial, but these are, again, are they conjugates? Yes, these are, again, conjugates. So I know the center terms are going to cancel, so I can just do 9x to the 4th, and then the product of the last ones are negative 16d squared. Saves us so much more time if we can see that those are conjugates when they are. And then this is also conjugate, right? So but it's a little bit different. So instead of a monomial like this one was, now the front of it is a binomial, minus 4d, that same binomial plus 4d. So we can think of this and this as 2 separate, almost binomials. And so it'll help us being able to visualize that. We'll be able to jump, just like we did with the conjugates here. It's going to be the first 2 things multiplied together. So in this case, 2x minus 5 quantity squared, and then the product of the other ones minus 16d squared, and then we just want to FOIL this out, because again, we're trying to simplify that. So that's going to be the first thing squared, 4x squared, the last thing squared plus 25, twice the product of the 2 things in between. So negative 20x, and then don't forget about your negative 16d squared. Okay? So just being able to sort of see that as a binomial, it's like almost like a fake binomial, but a binomial, and then the same binomial but with a plus, so those are sort of treat them as conjugates. All right, next one. This one's a little bit trickier. This one is going to take up a lot of room, so I'm going to move that up a little bit. So this is 2x plus y times 2x plus y times 2x plus y times 2x plus y. All right? So I would say stop this video and try this and see that you get the right answer. All right, so I could FOIL these 2 together and get 4x squared, twice the product of the 2, so that's going to be plus 4xy, and then plus y squared for the first 2, but I'm going to get the same thing over here, 4x squared plus 4xy plus y squared, and then we just want to basically expand all this out. So it's not really FOILing, but it's each term here gets multiplied by each term here. So in your next step, you're actually going to have 9 terms, right? Yeah, each of these by each of those. So these 2 together first. I'm going to try to write as small as I can because this is going to take up some space. So that's 16x to the 4th. Then we move over to here, plus 16x cubed y. Then move over here. We have plus 4x squared y squared. Then move over to the second term here with the first term. That's plus 16 x cubed y. Go over to the second term over here now. That is plus 16 x squared y squared. And then this one will be plus 4xy cubed. Go to these two. Trying not to cover them up so you can see that. These two, that's going to be plus 4x squared y squared. These two then, that's going to be plus 4xy cubed. And finally, plus y to the fourth. And then, of course, we want to combine all the like terms. So we get 16 x to the fourth. We get, here's an x cubed y. I think there's another x cubed y, another x cubed y there. So that's plus 32x cubed y. And then, let's see, what else we got? We have an x squared y squared here. We also have an x squared y squared here. X squared, let's see, what else do we have? Oh, another x squared. So we have 3 x squared y squares. So that looks like 24. So plus 24x squared y squared. You know, if you want to sort of underline them as you use them, try not to cross them out too much because then you'll kind of, it's hard to see them. And then it looks like I have an xy cubed and an xy cubed, so that's plus 8xy cubed. And then finally, I think it's just the y to the fourth. Y to the fourth. All right, so let's go on to, what is this, L, I guess. So we have a polynomial divided by a monomial. In that case, we think about using this monomial to divide each one of these things. So divide these two things together. Let's see, that's going to be 1 x to the fifth over x to the fourth. We're going to simplify that. That's going to be x. Y cubed over y squared, that's going to be y. Moving on to these two now, the ones in the middle. That's going to be an 8 divided by -4, so that's -2. The x to the fourths cancel. The y to the fifths is left. And then use it on the last one, so a negative divided by negative, that's going to be a +3. Look at the x's, that's going to leave us the x upstairs, the exponent's bigger, so that's going to be x to the third, and then the y squares cancel. So that would be your answer for that one, for L. All right, let's move on to, I think I have the back page. Oh yeah, the back page here. We have a couple more problems here, and so we're dividing here, and I want to start by dividing dividing long division. Now, you may or may not have learned how to long divide in middle school. Often, you're just given a calculator. But it's helpful if you know how to long divide here, so when we long divide using polynomials, dividing polynomials, it's a little bit easier if you understand how to long divide just with numbers. So let's try this out. So we're dividing 73,535 by 95. So first we say 95, does it go into 7? It does not, so we put a 0 above that. Does 95 go into 73? No, so we put a 0. So how many times does 95 go into the first 3 digits? 735. So that is 7 times. And so what I do, and I sort of know what the answer is, but sometimes that would take a little bit of figuring out, like, oh, does it go in 4 times? Does it go in 5 times? So if it goes in 7 times. And so so then I take and I multiply 7 times the 5, and that's 35. And I carry the 3 over here. And so I multiply 7 times 95 is what I'm doing. So, and I put the result down here. So 7 times 5 is 30. 7 times 5 is 35. 7 times 9 is 63. With 3 more, so that's 66. And I subtract that. Let me get rid of that 3 that I kind of temporarily put in there. And I'm going to subtract that. And that gives me 0. And then I have to, of course, borrow 1, so that's 70. All right, and then I bring down the next number, 3. So now I want to figure out how many times does 95 go into 703. And if you think about it, you'll see that it is 7. And I'm putting that 7 kind of right above the 3. And now I multiply that, and again, we know what that is because I just did that before. So 6, 6, 5, and I subtract again. All right, and so when I subtract that, of course, I'm going to have to borrow to get that, and that'll be 8, and I believe a 3. And then I bring down the next number, which is a 5. And now I ask myself, how many times does 95 go into 385? And if we think about that, that'll end up being 4. And so I multiply 4 times the 95. So 4 times 5, that's 20. Carry the 2. 4 times 9 is 36, plus 2 more is 38. And I subtract, and I get 5. Okay, I have no more numbers to bring down. Now, sometimes we would put a decimal point there and put a 0 and then bring down the 0 and just kind of keep going, right? Sometimes we do that. When we first started learning how to long divide, though, we would say, the remainder is 5. So we would say, the answer is 774 with a remainder of 5, right? And then later on, we learned how maybe we could take that and say the answer is 774 and 5/95, right? So we would like put that all together as almost like a mixed number, okay? So that's kind of similar to what happens when we do a long division using binomials. Okay, so let's try this. So if we're going to set it up very similarly, we're going to kind of set it up so that's like this. What we are dividing by goes out in front, just like here. With 95 was out in front, so x plus 2. And then we put the polynomial in descending order. So notice I mixed it up here. Got to have it in descending order. So 3x cubed plus 5x squared plus x plus 6. Okay. All right, so this is how we do this. We're going to see how, we didn't take 95 into the whole thing. We took it into various things. So we're going to take these two things into these two things. So what we first got to figure out, and we kind of sometimes would do this too, we would say how many times is 5? We were trying to do into 735, right? But sometimes it gets you close if you say, well, how many times does 9 go into, and then leave off the last digit here and the last digit here? So how many times does 9 go into 73, right? It's not always exact, but it gets you to the close number. So that's a similar thing to what we do here. We look at what times this the first term would give us this first term. So what times x gives us 3x cubed? And that would be 3x squared. And we put it above the like term. So x times 3x squared gives us our 3x cubed. And just like we did here, we took that 7 and multiplied it by this and put the result here. We're going to do the same thing. 3x squared times this binomial. And put the results here, these two spaces here. So I'm going to start with this one. So 3x squared times 2. That's 6x squared. And 3x squared times x, that's 3x cubed. Let me get rid of that line I put in there. And now I subtract, just like I did up here. I subtract. Now, we're subtracting, and almost always that will cause us problems. So I always recommend that instead of subtracting, it's this binomial minus this binomial, I'm going to add the opposites. All right, can you subtract without making a mistake? Sometimes, but not always. So I would suggest always, instead of subtract, add the opposites. All right, so what do we get? This goes away, right, this term, and that's kind of what we expect, right? If not, then you did something wrong. And this is negative x squared. Okay? And now we bring down the next term. So it's negative x squared plus x. And now we repeat the process. What times x gives me negative x squared? So that's negative x. Got to have, you're creating a polynomial up here, so you got to have a sign in front. So x times negative x is negative x squared. Now I take and I multiply this by these two terms and put the two results here. So negative x times 2, negative 2x. Negative x times x is negative x squared. And I subtract. But rather than subtract, I'm going to add the opposites. So now add these up, 3x. This, of course, cancels. It always should. Bring down the next term, plus 6. All right, what times x gives me 3x? That's plus 3. Notice the like terms are lining up. We have the x squared over the x squared, the x over the x, the constant over the constant. And this is nice because now I know when I'm done with this last step, I'm going to be done because there's nothing else to bring down. Just like I knew I was kind of done when I brought that 5 down and used it, I was done. So now 3 times this stuff. So that's going to be 3x and plus 6. I subtract. That's 0. So in this case, the remainder was 0. If this was 0, we wouldn't need a fraction. So we don't have a fraction here because the remainder is 0. Our answer is this. So when I take this polynomial and divide it by this binomial, I get this trinomial. All right, set up the next one and try it. You know what? I'm going to do it down here so I have more space. I don't want to get too tight up there, so maybe try it down here. So this is C. All right, so I'm going to do x squared. Now, I recommend if there's a missing term, like there is here, right? There's an x squared, there's no x term, put in 0x minus 1. Okay, and then make sure it's in descending order. It looks like it already is, but there is a missing x cubed there. I would recommend putting in that 0. So we have, x to the 5th minus x to the 4th minus 3x squared. Oh, sorry, I said to do it and I forgot. Plus 0x cubed minus 3x squared minus x minus 4. All right, now, so this is going to feel a little tedious because there's, a lot of work going on here. All right, so these 3 things are going to go into these 3 things. First, I'm going to say what times x, the first thing times what gives me this first thing. So x squared times what gives me x to the 5th. That's x cubed. And notice I put it above my x cubed. So I keep my like terms lined up. All right, I multiply these 3 things by this, and I put the result here. So that's going to be, it's going to be x to the 5th plus 0 x to the 4th, and then minus x cubed. I subtract. Only rather than subtract, I'm going to add the opposites. All right, so that goes away. This is going to be negative x to the 4th. This will be plus x cubed, and I bring down the next term, minus 3x squared, and I start again. What times x squared gives me negative x to the 4th? That's going to be negative x squared. Notice, like terms. Okay? Multiply each of these things. That's negative x to the 4th. It's negative x 0 negative 0x to the third, or plus, it doesn't really matter. I mean, it's 0. 0 is neither positive or negative. It's no big deal. And then this one is positive x squared, and I subtract. Only rather than subtract, I'm going to add the opposites. All right, this term goes away. This is going to give me x cubed. This is going to give me negative 4x squared. I bring down the next term. So again, this is a little bit more tedious because there's a lot of terms up here. 6 terms, so it's going to be, four times we have to go through this process. Okay, x squared times what gives me x cubed? That's just x. And I multiply. I get x cubed. I get plus 0x squared. And I get negative x. And I subtract. But rather than subtract, I'm going to add the opposites. Okay? All right, this gives me negative 4x squared. This gives me a 0 plus 0x. And I bring down the next term, negative 4. All right. What times x squared is negative 4x squared? That's negative 4. And now I multiply this by all 3 of these. So negative 4x squared minus 0x, or plus 0x, doesn't really matter, and plus 4. And I subtract. Now careful, often I see students put a 0 here. Instead of subtract, I'm going to add the opposites. So actually, this one has a remainder of negative 8. So what do we do with that? So the answer is this plus negative 8 divided by x squared minus 1. So this is our answer. All right. Now, I could, instead of writing plus and negative 8, I could move this negative down in front and say minus, and then the positive fraction. So 8 over x squared minus 1. You can do either one of those. Okay? Now, why is it a plus here? I mean, up here, when we did this long division, we wrote it as a mixed number. But what is like 7½ That's mathematically really 7 plus 1/2, isn't it? So we write a mixed number just with the whole part and then the fraction next to it, but that really is the same thing as 7 plus 1/2. And so that's really what we do here. It's this polynomial plus the remainder over the divisor, what we're dividing by. Okay? All right, so that's that. We have homework on this. I believe this homework is also on a worksheet. It's technically out of the book, but it is a worksheet. So homework R3.